Hi, this is Dr. Steve Graves with the California State University Northridge Geography Department and geographyplanet.org. This is part one of a two-part series on how to do regression analysis or statistical modeling using Microsoft Excel. What you see before you is some data that I have prepared. I have downloaded data from the California Department of Education, and that's in column C here. And what this represents is the average percentage of fifth grade children that are in the healthy fitness zone, according to the state of California, per school, but it's been aggregated at the zip code level. So some zip codes have multiple elementary schools, some had none. And so what you see here is in zip code 9001 to 50% of them are in the healthy fitness zone. And then what we're going to try to do is predict using statistical modeling, using a regression test. Why? We're trying to predict using all of these other variables that first column. So I have guessed that some of these variables, once they're combined together in a statistical model, we can run this regression test and it will tell us what percentage of the variation in fitness levels is predicted by a combination of these variables. This is extremely powerful statistical tool. It is challenging to use, and for introductory students, I don't expect you to be able to do this on your own from scratch, but I believe that it is very important that you at least know in general how it is done, and if you are leading an organization, that it can be done, and the basic parameters of how it works so that you could know what you're talking about, know what to look for if you were to hire a consultant to help you with it. So let's go ahead and get started on statistical modeling in Excel. So I suppose the first thing that we should do is to go over what these variables are. This first one is the dependent variable, the effect that we're trying to explain. These one in gray are standard variables about neighborhood characteristic, population density, and average household size oftentimes tell us things about fitness or health outcomes. Median age, it's age structure of the neighborhood, and these in gold are all ethnic percentages, and oftentimes those are good explanatory variables. This is percentage of people that have had no high school, percentages of people with a bachelor's of arts, percent BA, so education, income. And because I'm particularly interested in the retail structure of the neighborhood, these columns of data represent the number of limited service restaurants, the number of convenience stores, the number of, and limited service restaurants here, I should say, are fast food joints. These are sit-down restaurants, convenience stores, and supermarkets. And these represent a calculation that I did called location quotient, which is a measure of the retail density of fast food, sit-down restaurants, convenience stores, and supermarkets. And so any of these places that have a value of over 100 have more of those kinds of retail establishments than you would expect given the countywide average. Where the value is right at 100, similar to these, then they are about average. And so it's a measure of density of the stores as opposed to simply a raw number. It's important to note that all of these are a ratio. That's a rate. That's a rate. These are all rates, as is the population density. So most of these variables are going to have a range of from 0 to 100. And since this is a ratio data as well, they should all work together pretty seamlessly. So the next thing I would like to do is to go, well, before I do that, let's go to View and Split so that we can see our column headers even once we scroll to the bottom. And what I want to do is to calculate two things. Skewness, and you should remember that from earlier in the semester, and then we're going to do a quick correlation examination. So maybe I'll move this over just one here and broaden this, widen that. Skewness. So you may remember that was skew.p. So skew of all the population. So it's not a sample, it's every observation. So if I add a few decimal points to my outcome, then 0.22 is pretty low skewing. And I'm just going to copy that formula all the way across to underneath all of these. We should only be worried about values, skewness values, once they get above about 2. And so with conditional formatting, I could ask for the top 10%, and we see that we have a couple of these variables way over here, kind of useless, but percent black is skewed. And so that may turn out to be a challenging variable to use in the model by itself. Luckily, I have combined percent black with percent Hispanic. These are black folks that are not Hispanic, and these are all Hispanics regardless of race. To combine those two together, I've created percent brown, and that is not skewed, so that's a better candidate to use in the model. The next thing I want to do is do a quick correlation, Correll or Pearson, between the fitness percent column. So I've highlighted it. I'm going to press F4. To freeze the column, I pressed comma, and I'm going to highlight the exact same block of data, but not freeze it the second time. When I hit enter, that will complete the formula, and I should have a value of 1.0, indicating a perfect correlation between fitness percentage and fitness percentage. I'm going to copy that formula across, paste. I need to increase the decimal point here a little bit so I can see which of these correlations are strong. And this helps us, again I'm giving conditional formatting, this helps us identify the more likely candidates for inclusion in the model. It's not necessary, it's not 100% necessary. I'm going to extend this over here to these three variables here that are unique ID, perimeter, and area. And we should note that they should have very small correlations because there's no reason to think that fitness should have anything to do with the size of the zip code that you're in. But we have several candidates that look promising among the fast food ones, or the retail structure of the neighborhood, supermarkets, convenience stores, and fast food. Particularly fast food looks pretty good there. As the percentage of fast food goes up, the fitness goes down, so we may want to use that in our model. These are the raw numbers here, and they're all less useful. So we'll get rid of those. And then we look at, there's unemployment rate. That looks possibly useful. Median income looks useful. Percent renter is smaller. It could be useful. Percent bachelor's degree is tells us more about, or has a stronger correlation, so that might be something to use. It looks like it's a little stronger positive correlation, and no high school is negative correlation, but a smaller number than its partner. We see percent brown looks very powerful here at negative 0.73, and so does percent white, which is in many ways the opposite of that number. But percent Hispanic and percent black may also be useful in our formula. Median age looks strong. Average household size looks like it is also a possibility. And population density, it looks pretty weak. Now, these are not hard and fast rules, but these elements that I have marked with an X are probably pretty good candidates for us to use in our predictive model. So the next thing I'm going to do is I'm going to copy this entire data block, highlight, press copy, and I'm going to put it in a new sheet. You can put it in an entirely new workbook if you want. That's Control N, but I'm going to paste it here. And what I'm going to do is I'm going to keep zip and the fitness columns, B and C, here, but I'm going to highlight from D over to K, more or less, and then click Insert. And that's going to slide all of those things over. What I want to do next, I'm going to start grabbing the columns of data that I think might be useful, might be impactful predictors of the fitness percent, and I will copy them and move them over. So average household size was one that we thought might work. Boom, put it there. And I will continue until I have anywhere from 3 to about 7 variables.